We have Usha with us. Usha is the first Indian women Kegel grandmaster. She she has knowledge about machine learning, data science, deep learning, and today she is going to share with us how to get started with deep learning and specifically how to get started with deep learning using TensorFlow 2.0. So I hope you have a great session here and get to learn, get started your hands with the deep learning. I am also going to try it out. I have just my laptop here, and let's get started. So welcome, Usha. I'll hand over the stage to you. Thank you.
Thank you, Pradeep, for giving me an opportunity present in this platform. And yeah, let's get started with the topic. So about me, Pradeep has already introduced about the Kaggle Grandmaster thing, and I also lead several women in data science, women in machine learning and data science chapters for both Bangalore and Mysore. I'm also the organizer for TensorFlow User Group Mysore and Google Developers Group. You can follow me on Twitter for all the events we organize as a part of these communities. We have events every week. So the presentation and the code samples for this particular event, which I'm doing, is there in my GitHub repository, which is github.com/ushareng. You will find a repository called gitcommit.show. In that repository, you will find all the code samples and there. And you can also follow me on Twitter at urangaraju. And this presentation, you will have the links to all the meetup groups which I organize. So let's get started with today's topic. So what is traditional programming? What do we do in traditional programming? In traditional programming, you will have, you will give, you will code every line of how the machine should function. So if it's x is equal to y plus z, so you will code every line, sequence of instructions you give to the machines, and the machine will perform those sequential instructions. That's what you do in. You write the algorithm for it. You tell the machine what to do. But in machine learning, what you do is you give the answers and you give the data, and the machine will give you the rules. So unlike in a traditional programming where you give the rules and the machine performs the job for you. So today we'll be covering three use cases. The first thing is the hello world of ML. So in the hello world of ML, I'm going to code this particular piece of use case in TensorFlow 2.0. And then we'll also be covering image classification, a basic image classification called using fashion MNIST datasets. And the third use case we'll be covering is how to classify images again, a little more advanced compared to the MNIST, rock, paper, scissor, how to classify these images correctly. So coming back to the hello world of ML, so this hello world, this particular use case, what I'm going to do is x values -1, 0, 1, 2, 3, 4. For this corresponding x values, there are some y values. There is some relationship between these x and y values. Now I need the machine to tell me the rule which maps the x to the y value. And so if I'm going to give a new x value, the machine should correctly predict me the y value. So how to make the machine to do it? The first use case.
Usha, you can't hear you.
Can I share this Colab link?
Sure.
So how to share it with the audience?
Please share it in the chat. I'll share it.
So this is a particular notebook which the audience can execute it simultaneously. So yeah.
Great.
So
So you will find everyone. You will find this link in the question chat box. It's on live.kitcommit.show next to the live stream that you see there.
yeah. So what you'll have to do is, this is my notebook. What you'll have to do is go create, save a copy in Drive. There will be a new notebook for you which will be created under your Drive. So, and you should start executing that notebook. If you try to execute my notebook, it will not allow you to do. So the environment which I'm using for executing the code is CodeLab, which is a cloud platform from Google. It's a free online cloud platform which also gives you free GPU and TPU to execute it. So you go click on the link, click under file. You can create a new copy by clicking save a copy in Drive. A new version of this notebook will be created in your Drive, and you can start following along with me. You can start executing the code. So the first block of code is I'm going to import. I'll just zoom in my screen a bit so it's already zoomed. So the first block of code is importing the basic necessary libraries. So I would require Keras framework because it contains all the sequential layers which I need to create my neural network. So I'm importing TensorFlow library, NumPy, and the Keras framework. So if I want to create the most basic neural network, I'm just going to call the keras.sequential layer. I'm going to create a tens layer inside it. I'm going to pass one input. So I have these, and this is how you can create the most basic neural network where you give one input and expect one output. So this is the most basic model using keras.sequential layer. So I'm just going to code this problem.
Usha, can you go a little slower? Because just as you have shared this one step, people might be busy doing that right now. So can you just go a little slower and explain the details so I can follow you?
Yeah.
Thank you.
So this is a use case which I'm going to see. For each value of x, there is a y value. So I need to find the rule which maps the x to phi. So I'm going to do this using neural networks. So this is how I'm going to do. The first step is basic step, just importing the needed libraries. So we require TensorFlow. We also require Keras for building, which has a sequential layers for building a neural network, and NumPy library. So these are the three libraries which we require. We are importing those libraries. So the x, I'm using NumPy to create the x. So it is like this, right? X was a NumPy array and y is also a NumPy array. So I'm creating two arrays using NumPy library. NumPy np.array. NP is the alias for NumPy. np.array. I can create a NumPy array. So I'm just creating x and y NumPy array. So my basic model is a model which has only one layer. It will accept one input, and it is just a single layered neural network. So I can build a neural network using the sequential layers of the Keras framework. I'm just having only one layer in my neural network. This is a very basic neural network which maps the input to the output. You're just mapping the X to the out. So I require only one layer. So this is a very basic layer. It accepts only one input, which is the X values. So this is my basic model for this. And I'm executing my model. So this model will have random parameters. I'll be explaining you what these parameters are as we go in each and every use case. So you might have some gaps and you might not understand certain things while we discuss each thing, but over a period of time, you'll be able to pick up the concepts. So this is my basic model. This model will map my input to output. My input was X values and my output was some Y values. So it will just map this thing, and it will have random parameters assigned in the beginning. So it will give me an output. So the output will be again mapped to the, it will be checked with the Y, whether the machine has predicted it correctly. So initially, since I'm starting with a random parameters, it might not have predicted properly. So there will be some errors associated with it. That errors is what is loss function. Loss function will capture how accurately your machine has made the prediction. So at each step, it will keep calculating this, how close the machine has predicted machine has made the prediction. So this will be captured in loss function. So your will be able to optimizer is what will be regulating this loss function. So these two terminologies you'll be able to understand much better when we go to the next use case. So for now, you just understand there are two functions which are present. One is the loss function, which will keep a tab on how accurately the machine has made, found the corresponding Y value for your X value. If it has predicted correctly, then the loss will be zero. If it is not predicted correctly, so there will be some component of loss function which is associated with it. This optimizer will reduce the loss function. Your objective is to reduce the loss function. So this optimizer is some function which will keep regulating this loss component. So these two are the parameters which I am passing to the my compile method of my model. So now I have created a basic neural network. I have my input data and my output, and I've created a basic neural network. For the parameters of the neural network, I've passed, which is the loss and which is the optimizer and all this. Now I'm fitting the data to my model using a method called fit. And I'm giving 500 epochs. So it will perform this operation 500 times. So at each time it will calculate the loss function, and then the optimizer will regulate the loss function. This will happen 500 times. So after that is present, now if I give some input value 10, and if I ask the model to predict, it will give me my output. So for this, it will give you a very close output. For 10, it should correspond to 19. You will get something on the lines of, so it's still running. So this is the first use case. So we'll come back to what the output is after some time. Let's not wait for the neural network to keep running. So it's 248 epochs. So it's almost close, 470, 443. So it's done. So the model is being built. Now I have built my model. I am just giving a random number 10, and I want the model to predict the corresponding Y value. So it has spit out 30. So it has mapped, so 31 should have been the right number. So it is giving something very close to that 31, 30. So this is how, this is a basic hello world of neural networks. Let's quickly revise what all we did here. So what we did was we had X set of X values and set of Y values. And we want the machine learning algorithm to understand the rules. You have given the data. The machine learning should give you the rule which maps the X value to the Y value. This is the use case. This is what you want to achieve. How do you achieve it? Yeah. So we started by importing the necessary libraries. We imported the TensorFlow libraries. NumPy, we wanted to create two array of NumPy arrays. So array of input and output. So that's why we use NumPy arrays. And we use a Keras framework, which has the sequential layers to build the neural network model. So that's why we import the Keras library. So the basic neural network is what here. So we use this keras.sequential thing where we built a single dense layer and we give only which accepts only one input, which is the X, and it has to give you the one output, which is the Y. This is a very basic neural network. And we are passing two parameters to the model. One is the loss function. Loss function is, so for a given X value, at the first, it is just assuming random parameters. So random weights and random biases. So for a given X value, at first, it will predict something very wrong. So it will make comparison between the value it predicted to the actual value. So that is the loss component. So our objective is that is the loss component which will get stored in the loss. And there is another parameter called optimizer, which the role of the optimizer is to minimize this loss. So these are two important components here. And then I'm just fitting the model. In fitting, I'm just giving the input and output, and I'm performing these operation 500 times till my output is as close to the predicted value. So this is the basic, hello world of machine learning using TensorFlow 2.0. This is the first use case. Now let's advance to a much intermediate level of task. Here we're going to look at another image classification problem, which is called fashion MNIST. So fashion MNIST is, if you can I'll just go to the presentation mode so you can see my screen better. So fashion MNIST is, there are 10 objects. So one is the t-shirt, the other is the pant, the other is shoes, then handbags. So like this, there are 10 objects. So the job of the machine learning algorithm is to learn this data set. And if you give a new object, which is one of the 10 items, it has to make the correct predictions. So fashion MNIST has got 10 different objects. It's a repository of all these objects like the shoes, handbags, and then the t-shirts, the pants, and all these things. So the model has to learn the patterns from this data, and when you give a new object, it has to make the prediction correctly. So this is the use case we're going to see. This is the data set. Fashion MNIST is similar to another data set called MNIST. MNIST is nothing but it's a handwritten digits. So it's handwritten digits from 0 to 9, and 0 to 9. It is a huge repository of this handwritten digits. The machine has to learn the patterns using these handwritten digits. And when you give a new handwritten digit, it has to make the prediction. This is what is MNIST dataset. Just modified version of MNIST dataset is fashion MNIST. Instead of handwritten digits, you're having some 10 grayscale images, grayscale image objects. So handbag, pants, shirts, and all. So this is the data set, and we are going to train an image classifier which will learn from this fashion, which will learn the pattern from this fashion MNIST. And then when you give a new object, one of the different image of one of the 10 items, if you give a different image of one of the 10 items, it has to make the correct prediction which of the 10 object is that image. So this is the goal. So we're going to achieve that using.
Usha, there is a question. Can you answer it? Can I interrupt you?
Yeah, tell me.
Okay, so the question, there is a question from the audience. Does it tell us the resulting rule or the equation it is applying? In this case, y equal to 3x plus 1, etc.
No, it will not tell you the resulting rule.
Okay, please go ahead.
Yeah. So we are going to import the library. So the needed libraries, TensorFlow and Keras. So all the libraries like Matplotlib, here we are having another library called Matplotlib, which is a data visualization library. So this is my fashion MNS data set. You can just Google it. There are around 70,000 images. So in the Keras package, these are very famous data sets. So if you go to Keras, like if you go to Keras dot data sets, all these packages are preloaded for you. That is for beginners who wanted to quickly learn machine learning. So they've preloaded some packages for some data sets for you, which I was discussing this MNS data set, right? So this MNS data set is already loaded for you in the keras.dataset package. So MNist is there. So and built in, there are some 6 to 7 built-in data set, both in text and in images. So you can make use of these built-in. If you're an absolute beginner, then this session is focused towards an absolute beginner. I'm just putting it across somebody who doesn't know machine learning and somebody has some experience in programming, and that's whom the session is targeted towards. And so you've got some already available 7 data sets. So when you're getting started with your machine learning journey, there are other important things which you need to focus on. So keras.datasets has got already some data sets uploaded for you, so you can make use of it. It reduces your workload. So what I'm going to do in my code is I'm just going to, there is a load function. Using that load function, I've already imported the Keras packages. So using keras.datasets.fashion.mnist, I'm directly storing it in fashion.mnist. Then I'm using a method called load underscore data, and which will give me 4 values, which is train images, train labels, test images, test labels. So you have to see for any other new data set, there's a set of codes of line. At least you need to write some 5 to 6 lines of code, to get the data set, then to make classification of test, train images, and all of it. So all that is just saved for you. You just have to write to, if you just use the predefined data sets, which is loaded on the Keras website, you just get 2 lines of code. You're just getting the data set categorized under different buckets. So there are 4 buckets here: train images, train labels, test images, test labels. So what are these 4 buckets? So train images is, we saw fashion MNist has got 70,000 images. Out of the 70,000 images, what I'm going to do is I'm going to take 10,000 images and I'm going to keep it separately, and I'm going to take the 60,000 images, keep it separately. This 60,000 image, out of these 60,000 image, so I'm first major classification, which why I'm making this classification, I'll come back to it later. So I have 70,000 images in total. Out of this, the first classification which I make is I take 60,000 separately and 10,000 separately. I separate it. This is the first classification. The first 2 buckets are test data and trade data. And amongst that 60,000 images, if you see, these are the images, these are pans, but I need a label, right? So this is pants. So if there is an image, and there should also be a label which tells me this is pant, right? So that is what is label and images. So if you see, the label is nothing but trouser is mapped to a number 1, and pullover is mapped to a number 2, and dress is mapped to number 3. So the machine learning will not, tell you words. So the output of the machine learning algorithm is not going to be trouser or dress. It's not going to spit out trouser or dress. It will spit out some numerical value. That numerical value will correspond to a particular class. So this is what is label. So there were four buckets we saw. One was train images, train labels, test images, and test labels. What are those? Each individual buckets is what I'm explaining now. Machine learning is not going to give you a categorical output or something in words. It's going to give you a numerical output. So you are mapping each of these images, like all the dress images, to a particular number. So all the dresses will have a label called 3. So when a machine learning a model spits out 3, then you identify, okay, it is saying this particular image is dress. So that is this label. So I'm giving an explanation of what these 4 buckets are. So there are 70,000 images. I've split into 60 and 10,000 images. And that is the first major classification, which is train. And the major 60,000 I'm naming as training data set, and the remaining 10,000 I'm naming it as test data set. Out of these 60,000 images, I have images and something called label. That is, each image is mapped to a number, a numerical number, that is label. All this I don't have to do manually. I just have to call this load data method, which will do the job for me. There are 7 other, so you learn the concepts now. You can go and practice, test the same concepts with the other 6 data sets, which is there in the keras.datasets website. So these are my class names. So my training images, the images is there are 60,000 image, and the shape of the image is 28 by 28 pixels. So the labels, there are 60,000 labels. For 60,000 images, the corresponding 60,000 labels. And each label will correspond to a number between 0 and 1. So I forgot to share this notebook with you guys. Wait, I'll just share this notebook. You can also, similar to the first notebook, I think, since there are a lot of epochs, if you parallelly start running it, it might take long time. But after the session is over, you can start executing it at home. So this is the notebook. I think the sharing privileges is anybody can view. Anybody with the link is view. This is a sharing privilege which I have given. Yeah, anybody on the internet can view it. So you can parallelly execute these notebooks. So each piece of code has got some explanation above it. So you can read that and you can understand it, self-explanatory as well. And what you have to do is you have to go to file, click on save copy in drive. When you click it, a new version of the notebook will be created in your drive, and you can start executing that notebook. If you try to execute click the link and try to execute my notebook, it will not let you do it. So this is what is my 4 buckets, which I classified. Now, what I'm going to do is, so I'm just printing out the matplotlib. I imported one library, right? I'm using that library. I'll not get into the specifics of explaining what matplotlib is, how to visualize it, because that's not the focus of the session. I'm just explaining this piece of code using the matplotlib library. I'm just trying to visualize one particular image. So this image is nothing but shoe. So if you see these training images, each value will be between, if you say an image pixel, if you take an image, it is a 28 by 28 pixel. So I'll just show you in Google. Let's see if the right diagram comes up. So if you take this image, this particular image will be 28 by 28 pixel, and each pixel will have a value. That value can range from 0 to 255. So what we want is, we want that value to be between 0 to 1. So that's why in this piece of code, we try to divide it by 255, so that each pixel value will be a value between 0 to 1. So you take the train images and you take the test images, you divide that each pixel value by 255, or this process is called normalization. So now all this, each pixel can take a value from any value from 0 to 255. You're normalizing it by dividing by 255. That's what this piece of code is doing. And again, I'm using matplotlib to visualize a bunch of images. That's what this piece of code. Now I'm coming to the building the model. This is my basic model. The task is MNS, fashion MNS data set. I explained to you what the data set. What my model has to do is, I have to learn the patterns using these 60,000 images. 10,000 images, I've kept it separately called test data sets. I'm not touching those 10,000 images, which I've kept it under the different bucket called test data set. This 60,000, using the 60,000 images, what my machine learning model has to do is it has to learn the pattern, and when you give a new image, it has to make a prediction correctly. So I'm building a basic model. So this basic model, again, last class, last use case, we saw a keras.sequential. We used it to build one single layered model, right? Only one dense network was there, only one layer was there, which will accept one input and it will give one output. That was the use case which we saw previously. Now we are going to have few more layers. So this image is a 28 by 28 pixel. So the first layer, what I'm going to do is I'm going to flatten out this 28 by 28 layer. So the 28 by 28 layer, I'm going to flatten it out. It will, so 28 into 28, if you flatten it out, it will be 784 pixels. So it will be a straight flat layer. And that straight flat layer, so I'll just show you how it will look like. So this will be like this. So 28 by 28, I'm just flattening it out as one single layer of 784. So this is my first layer. This is how my first layer will look like. So I'm just saying the first layer is flatten it, and the input shape which I'm giving is 28 by 28, which each image will have a 28 by 28 pixel. I'm just flattening it out. The second layer is 128. So if you see the second layer, this first layer is 784 nodes. It has 784 nodes. The second layer has got 128 nodes. It's a dense layer, which is nothing but there will be 128 nodes. So that is what they have. 128 nodes is 0 to 127, which is nothing but the 128. All these orange boxes is the second layer, which is the 128 nodes. So the dense layer where I'm having the 128 nodes. So I'm using an activation function called ReLU. I'll come back to what is ReLU. And then I'm using a third function. The third function is just 10. So the 10 stands for the output. You have 10 objects, right? That is the shoe, handbag, t-shirt, and all these 10 objects are there, 10 labels. So the third layer is nothing but 10. So it will take any input image, then you will have some functions which will spit out the 10, your output is your 10 objects. So this is what is the model. So I'm building a very basic model. So after I'm basic model, here again I'm having something called the same component which I had, optimizer which regulates the loss function. The loss function which I'm using here is sparse category. There are a lot of loss functions available. I'm using sparse categorical, cross entropy functions. Let's come back to all these things. And the metrics which I'm using is accuracy. Now I'm building a model. I think if I execute it, it might take long time to execute it. So the output is already visible in your notebook. If you see, scroll down the notebook, the output is already visible. So I'm just fitting the model using the images and the labels. I'm giving 10 epochs. Last use case we saw it was 500 times it was repeating the procedure. Here I'm just giving 10 epochs. And then I can just evaluate it. So the reason why we split it into different buckets like train and test is you kept aside a certain list of so out of your total input data, you kept aside some out of your total data set, you kept aside a certain portion of your data so that you can evaluate. Now you have built your model, you have compiled it, you have fitted, everything is over. Now you have kept aside some 10,000 images. What you can see is you can verify how good your model was by testing out your model in all those 10,000 images. So you kept aside some 10,000, a bucket of 10,000 images aside in the beginning. So you can test out how good your model is. Using evaluate function, you're passing the test image and test labels. And the metric you are using is accuracy, how accurate is good, and it is the model is in making a prediction. So I'll just skip the rest of the lines of code because I'll have time to introduce the next use cases, new use case. So I'll just skip. I'll just go through this use case again. If you don't understand this use case, the next use case will be difficult to understand. So what did was the fashion M&S data sets contains 10 different image objects, and the objective is to build a model, image classification model, to make classify each of these objects. This is the objective of the things. So I'm importing the necessary libraries which I require. So this is my fashion M&S data set and all the 10 objects. So what I do is this fashion M&S is a part of preloaded data set in Keras.dataset website. So all I have to do is use a load underscore data method to load, to get the data and store it in 4 different buckets. So the 4 different buckets are, I have the train images and train labels, test images and test labels. So out of my total data set, I'm keeping aside a certain portion of my data to evaluate my model at a later stage. That is what is test images and test labels. Labels, I told you, the algorithm model is not going to spit out some words or something like that. It will spit out a numerical value. So you're mapping each and every object to a numerical code 0 to 9. So all the 10 objects. So that is what is stored in labels. And I'm building a very simple model. So what my model does is the first layer will be the first layer is a sequential layer. So each layer will come one after the other. So first layer is before building my model, I'm doing something called normalization. I'm bringing all the values in the pixel, which pixel can have a value between 0 to 255. So I'm just, in order to make it come to a value between 0 to 1, I'm dividing it by 255 and I'm building a simple model. The first is a flattening layer. So all this 28 by 28 pixels, I'm just flattening it into a single layer. That's a flattened layer. That's the first layer. And the second layer is nothing but, so the second layer is the 128 nodes. So this is the dense layer, which has got the 128 nodes. And the last layer is the output layer, which is the 0 object between 0 to 9. So these are the 3 layers which are available. And so this is a basic model. And then just like the previous example, we have optimizer, loss. We have one more thing called accuracy, which is a metric which we use to evaluate how good the model was. Then you use fit method. You give the training images and labels as the input. And then once the model is built, now you can evaluate the model using the test data which you kept aside in the beginning. So this is a basic image classification example using TensorFlow 2.0. I'll explain one more use case. I'll not get into depth of it. I'll just skim through the last use case. So the last use case here is this. So you have some images like this, like, rock, paper, scissors, like this is a very famous example. So you have a lot of images under these 3 categories. For fashion M&S, you had 9 categories, 10 categories. Here you're just having 3 categories. Under each category, you have a lot of images. So instead of using simple neural network, which we created some time back, we're going to use something called convolution neural network. So convolution neural network has got different concepts associated with it. So for convolution neural network, what is the concept is, for each portion of the in the image, you will be taking each portion. So you will be basically from all these images, you will be basically extracting some features. That will be the first process. Then your layers and all this will come. Before all these layers, dense layers and all this comes, you will be having a layer which just extracts the features from these images. So how do you extract features from these images? You have something called filters. So for this particular area, this is these are the pixel values for this particular highlighted area. So I have some parameters called, this is the red option is called the filters. So if you want to calculate the new pixel in this particular area, then the way you do it is you just multiply 0 into -1 plus 64 into 0 plus 128 into -2. So filter is something which will give you a new set of values. So the reason why you use filter is you for certain set of filters can highlight certain features. Certain set of filters can highlight certain different features. So you basically learn different features using these filters. There is not much of time to cover. We just have 50 minutes, and there's a lot of concepts in convolutional neural networks. So there's another concept called max pooling. So max pooling is nothing but I'll be explaining these concepts the second time. So if you don't get it the first time, you'll be able to get it. So max pooling is nothing but there's the four boxes. Out of these four boxes, max pooling. So the maximum value out of these four boxes is 192. The 192 will be, so a big image will be contracted, it will be made into a smaller image, because out of these this particular portion where there are 4 pixels, you're just picking up the maximal value. So you've reduced that big portion into a very small portion. So this is the big portion which has 4 into 4 size. You have made it into 2 by 2. So you are actually making a reduction in the number of pixels. So by doing max pooling, so max pooling is nothing but you're taking the first portion. Out of this portion, you're just picking up the maximum value. So I'll just quickly walk through how this particular use case is. So this particular use cases, you have something called the data set has something called 3 kinds of images. One is the rock, paper, and scissors. So you have to correctly, the machine learning algorithm has to learn the patterns using these input data set, and it has to correctly, if you give a new, out of these 3 categories, if you give a new category, it has to correctly classify which category the image belongs to. So we learn different concepts like filters, we learn concepts like max pooling and all this. So these, how do you determine the value of filter? You might have some questions like how the value of filters and all are determined. So initially you start with a random set of values, and then these are called, these values will be learned over a period of time. So these are values which, these are the parameters of the model which will be learned over a period of time. So I'm just sharing this notebook. This is the, I'll not get into depth of this use case because of the lack of time, but yeah, this is a there was a question. Yes, this is a classification problem.
Your
So there is,
screen is not shared. Can you?
so there is another notebook which I've shared with the audience. You can actually use that notebook to walk along. I'll not get into the depth of it. I'm just skimming through the notebook because of the lack of time.
Your
So what
screen is
the
not visible, Usha.
So for how long was the screen not visible?
So you
Okay.
can repeat again just from the last paragraph.
Okay. So this is the what I'm actually doing is, okay, this use case what I was dealing with is rock paper scissors. This particular thing is I have set of images under each category, and the algorithm will use this data set to train itself, and then It has to make the predictions correctly when you give a new image. So this is basically a classification problem. So I've just shared a notebook with you all for this particular.
Can you quickly go through the third case? Is what people are saying that they couldn't see the presentation.
So this is, oh, they couldn't see the presentation, is it?
For the third case.
Oh, okay. So I'm just walking through the notebook. As and when I walk through the notebook, I'll explain the concepts. I'll go back and forth. I'll go through the presentation and explain it. So this piece of notebook is shared with you in the comment section. Just open the notebook, create a new copy of this notebook, and start executing it along. And so the first piece of code is this particular image data set is stored in a particular location. You will just get the data set from that location and download it. And then you use some functions from zip file, you use some utilities to unzip it. And then you use os.path utilities to put it in a certain directory. And then you're just using matplotlib to visualize all these images. So this is the important part. You have some function called utility called under keras.preprocessing image. You have an utility called image data generator. So the first three sections which I covered was nothing but getting the data set from a certain location and downloading it using wget utility. That was the first thing. Using wget utility, I'm downloading a data set from a certain location. Then I'm using zip file utility to unzip it. It's a zip file, so I'm unzipping it. Then I am using os.path.join method to actually put it in a certain directory in a certain way, like temp.rps.rock. So there were three categories of images, right? Rock, paper, and scissors. So under each category, under the path, you're just storing those images. You've downloaded the images under each this directory, the rock images will be stored. Under paper category, the paper images. So if for the previous fashion MNS dataset, it was a preloaded dataset in the Keras dataset utility. So I already had the labels. But not all the datasets which you create, custom datasets, you might have to label it as well. You need require to manually label it. There are some softwares for you which will which will help you do it and all. But in this case, what we are doing is we are putting the images under the respective directories. If you do that, then you can use some utility from the Keras pre-processing thing. So all the rock images are under the category under the directory rock, and all the images rock paper images are under the directory paper, and all the scissor images are under the directory scissors. So all the images are under the corresponding directories. Then you can use, because you don't have labels in this data set, there is a utility called image data generator. If you use this utility, it will automatically create the corresponding labels for you using that directory folder name. It'll read, okay, the rock, these images are under the folder rock, so it will give the label rock. So it will automatically create the labels for you. The image data generator utility will automatically do it. So that is what is this piece of code. Then this is just normalization divided by 255 and all that. So this is what is the model. So I was telling you this, there were three layers which I was explaining to you. One is the convolution layer, max pooling layer. So this I'll just describe, for this use case, see there's so much about CNN, but this is a very beginner level introduction. So I don't want anyone to get overwhelmed. So I've just put the minimal concepts. So if you want to learn more, then if you can go to official documentation of TensorFlow, you will have a lot of tutorials starting from beginners to experts. So for this, since it's a beginner introduction, I've put the very bare minimum concepts for you to get started, but this is not the entire thing of CNN. So this is my simple model for the classification of rock, paper, scissor. So I'm using tf.keras.model sequential. Under this, I'm wrapping my entire all the layers. So what is this convolution? I'm using a layer called con2d, and it has one first parameter called 64. The 64 is nothing but filter. And input shape is the image input. The input shape is the shape of the image. So this particular image has got 150 into 150. It has got 3 channels because it's a colored image. So we were seeing grayscale images in Fashion MNS. This is a colored images. So you have 3 channels. So what is this 64? Again, you are having another. There are around 4 convolutional 2D layers, and it has got some first parameter like 64, and the third and fourth convolutional 2D layers has got 128 and 128. What are the 64s and 128? I'll just show the diagram and I'll explain it to you again. And you have something called max pooling, 2 by 2. So what is this max pooling? So that is also you are going, I'll be showing it to again. So this particular piece of model, this particular piece of code is what where you're building the model. So it has got around 4 layers of convolution and max pooling itself. You're repeating it, and you're using something called dropout, and then there are a couple of dense layers we have already seen it in the first 2 use cases. The flatten also we saw it in the previous use case. There's one more thing called dropout which is coming up. I'll explain you why you use dropout. So the 3 concepts which I have to explain in this particular model is this 64, and what is max pooling, what is con 2D, and what is dropout. I'll just use these slides to explain those things. So if you take one difference between the previous use case and this use case which we saw is, in this use case, you're trying to extract the features first before passing it inside the model. To extract the features, we are having something called filters. So you are having these filters. I'm using these filters to highlight a certain portion in this image. So if this is the so this particular area of this image, I have it in the form of pixels here. So filter is a set of parameters. So these parameters will be learned by the model. The model will be learning it. So you have some 3 by 3 filter. You have some values in it. So how are the new values? You're passing this filter. That 64 was nothing but that value is nothing but the filter. So how are you going to calculate the new value? So the new value for each particular pixel, how will you calculate the new value? So the new pixel value. So if I'm going, the highlighted pixel is 192, and the filter is what is in the red color. So this particular first box is nothing but a certain portion in the image is what is this first box. The second box is nothing but a filter. So in this particular first box, I'm just taking one particular pixel, 192. So I am passing it through a filter. After passing through this filter, it will give me a new value. How is that new value calculated? That new value is calculated by nothing but for each of its neighbors, it has to multiply 0 into minus 1 plus 64 into into 0 plus 128 into minus 2. So this particular slide will teach you how you're passing a certain portion of an image and through a filter, and how you get the new value. So basically you use this filters to highlight. So this is an image which I'm giving, I'm using filter. So, and I'm getting this particular thing. So there are certain particular portion of the image which is being highlighted. So you use these filters to extract the important features. There was one more layer called max pooling, right? So what this max pooling does, I was writing 2 by 2 and all, right? So see, if you take this max pooling is nothing but you're taking original image and you're trying to reduce the dimensions of the original image. So if you take these 4 by 4 a portion of the image which is 4 by 4, what I'm trying to do is I'm taking a 2 by 2 pooling layer. So I'm just placing the first 4 boxes. I'm placing my the pooling size was 2 by 2 as I mentioned in my model. So I'm just placing the taking the first 2 by 2 4 pixels, and out of this I'm trying to find it is max pooling. So it will find the maximum of those 4 values. The maximum of those 4 values is 192. So for every 4 pixels, it will find the maximum of the values. So after you do pooling, this entire 4 by 4 matrix is reduced into 2 by 2 matrix. So you're basically trying to reduce the dimensions. You're trying to capture only the important features of it. So this is what you try to do in pooling, and you try to do in filter. So these were the 2 layers. So you have image, And before, in the compared to the previous use case, in this use case, what you do is for each and every image, you're extracting certain features. So that is why you had this convolution 2 layers, and then you had this max pooling layers and all that. And you had 4 such layers. Pairing of convolution max pooling, you had 4 such layers, and then you had a layer called dense. It's nothing but set of nodes, and the finally output node, you had only 3 classes, which is rock, paper, and scissors. So this is the explanation for the neural network, which is present here. So this is the explanation for each and every fields which is present there. Then similar to last method, you just have to compile. You're passing the loss function optimizer metric. And then in the fit method, here you're passing something called train generator. So remember, this use case is different from the previous use case in a way that we don't have labels here. So what we did was we downloaded the data into corresponding folders, and we used a utility called image data generator, which will automatically find the labels for us. So that's why you, instead of passing X and Y values, you're passing something called train generator here. Then the same way, you're just making a prediction similar to the previous model. So we just saw 3 use cases right now. We started with the hello world of machine learning, where we had we started with hello world of machine learning, where we had X rows and Y rows. The machine learning algorithm actually has to find the pattern from a rule from the X to Y. And we did this using a single layer, and which takes one input and one output. We also saw something like optimizers, loss functions, and all that. And then we saw the second use case like fashion reminisce. These are grayscale images. These are uploaded for you in the keras.dataset website itself. And you just use the load method to download it, and then you categorized into 4 buckets. And then you built a basic model which had just one layer flattened, and then you had dense and the output layer, very basic model. And then you compiled that fit, and then made a prediction. And the third was a little different. This was the second use case. The third was little different. You had a color image. So the basic model which we did, neural network which we built, will not work out. So we we built a convolutional neural network here. So again, the use cases is you have 3 categories of images, and you just have to build a basic image classification model. So we use something called filters, max pooling, and all to extract features from it. And then we had the similar layers like dense and output. So this is brings us to the end of the presentation. So you can find the slides. I'll also share the slides with you. Uh, so this is just a basic overview for somebody who has never heard of machine learning, but has some programming experience, has never done programming in TensorFlow. This is a beginner level introduction for you to get started with deep learning using TensorFlow. But that being said, if you have picked up things in this class, and if you want to go and learn further, then you can go to the official TensorFlow website, where so I've just put the slides, and I'll also share my GitHub repository for this particular, where this repository contains all my notebooks. And just go to this repository and check out my slides and all my notebooks. And the last link is the GitHub repository, so where you'll find. And if you want to learn more, see, this is just an overview for you to get started. There's so many concepts here. If you want to learn more, you go to TensorFlow official documentation, where you have a quick start tutorial for beginners. And then, it takes you from the beginner level to intermediate level, and you have something for experts and advanced concepts as well. So you can use the TensorFlow official documentation. They also have provided the links to the official documentation, and the TensorFlow team maintains the YouTube channel as well, where there are a lot of video tutorials for you to get started with. And I do hope you've got this session has given you some quick start to get will help you get a quick start in deep learning using TensorFlow. And if there are any questions, I can take it now.
Wonderful. Thank you, Usha, for this wonderful presentation. We have lots of questions here, so I'll be asking them one by one. But before that, let me make an announcement for everyone. I have shared a link in the chat for submitting your feedback. People who submit their feedback, they'll get an awesome giveaway, such as cloud credits, and there are many other more things. So, and it will be shared only for people who submit their feedback. Now, coming to the questions, there are questions, many questions actually by people. So let me go through them one by one. So, first thing, I think the last slide was for rock, paper, scissors notebook, right?
Yeah.
Okay, so someone who's asking for the notebook, it's been shared in the chat. Okay, if you are watching somewhere else like Twitch or YouTube or somewhere else, please go to live.gitcommit.show to find the chats that we are talking about. And also please show some appreciation by clapping. There is a button on claps for the speaker here on the live.gitcommit.show. Now,
See, all the notebooks, I'll also tell you one thing. All the notebooks and the slides used in this presentation are there in my GitHub repository under the folder github.show.
got it.
And all the resources which I've used for the workshops are Colab notebooks. It's a cloud-based environment offered for free GPU and TPU by Google. And the reason why I've used Colab is for you to, I'm not sure which environment you're watching this from. If you watched it using Zoom and if you have clicked on the link, as I was explaining you could have parallelly executed the code and you could have checked it out.
Okay, got it. So we will. So you don't need to worry about the presentation or the code. We will share that on our GitHub repo. So Usha, if you can just name this appropriately, like what is this code about, and also share all the notebooks. I think you have it in one repo, so that's great. So we'll link that repo to Git GCS 2020 repo, Git commit show 2020 repo. So you're not just this presentation, you'll find all the presentation over there. So now let's focus on questions for now. So notebook is cleared. There is a person who asked why not average rather than max.
So this is just one type of pooling layer which you're applying. So you can try out average as well. You can try out different pooling layers. So I'm just showing you a very basic example. So I've used max pooling layer. So average pooling layer is known to have a better accuracy compared to max pooling layer. So you use it use case by use case. You decide on what pooling layer you have to use and stuff. So even if you take the filters, so there are different filters of different sizes as well. And so there are so many concepts which we haven't covered, like data augmentation, and we haven't covered dropout and all these concepts. So this is a very basic example. So for you to get started, so you can try out the other pooling layers. Maybe you can try out average pooling layer on this example.
Got it. There is another question. How do we decide which loss function?
So the loss function is again for based on your use case as well. There are several loss functions. So one thing which I would like to stop here and take you to this thing is, so you will have to go see for you to get the ABCD of deep learning and TensorFlow. I showed you, took a basic example and explained the basic things. But there are several possible loss functions which you will decide based on the use case. But if you want to go, this is keras.io, which is the official Keras documentation. So you go there, then you have Keras API reference here. So you can also go to the TensorFlow website and you can check out as well. So TensorFlow website and you can check out the API as well. And TensorFlow 2.0 is built on top of Keras. So the same loss functions is what you'll be using here. So if you take the metrics, losses, and all these things, so you've got the all the loss functions. You will be having mean squared error. Why you use this loss function? So you use this loss function. So what are the regression for all the regression problems? What are the loss functions which will be used? And for all the classification problems, what are the loss functions which will be used? And in classification itself, there are several possible loss functions which you can use. And for which problem kind of thing, which kind of loss functions is most beneficial. All these details for losses losses, then you have for metrics. See, we dealt with optimizers, metrics, losses, and all these things, right? And even for layers, we use some layers like dense. We use some certain layers and all, right? So all these things is present in this Keras official documentation. You can also use TensorFlow 2.0 documentation directly, or anything works. You can just go to the documentation and check out why we use certain loss functions, why we use a certain metrics, and all these things.
Got it. Thank you for the answer. One more question is, why do we use a ReLU activation function?
So the ReLU activation function is you have some 9 objects, right? 0 to 10 objects, right? So it will give you ignore you. I'll just show you the activation function here. Or this particular thing has got. So you have different types of activation functions. So like ReLU, and there is another thing called softmax activation functions. So what ReLU does is, so if it is any value between which is less than zero, it will which if it is less than zero, if you're getting the output of the neural network, so your neural network will actually, the model which you built will give you an output, right? That output, if the output is any value which is a negative value, it will take it as zero. So if you see this graph, this is the graph for ReLU activation function. So for any value which is negative, the output will be taken as zero. And for every other value for above zero, it will just take the corresponding value. So this is the ReLU activation function. So if you take the classification example which we dealt, we used another activation function called softmax. So I'll just show you that activation function also. So this is the softmax activation function. I'm getting the right diagram. So I will just check if it's explained in the slide. So for you have another activation function like softmax, but I'm not getting the right diagram to. So see, there is something called, this model will actually split out something called logits. So the softmax function will take that and it will give me a value between 0 to 1, a probability between 0 to 1. So there are several activation functions which will be like, so this particular use case is again used for MNIST data set. So there you use several activation there are several activation function based on what your output should be. Based on that, you decide what kind of activation function you should use. So again, you should go to the API where you can check out all the activation functions and all that. And the question that you asked was, why do you use ReLU and what does ReLU do? So I just showed you what ReLU does. So if it's any value which is less than zero, it will take it as zero. And for every other value, it will print out the same value. So we had the label 0 to 9, right? So we never had any negative values and all that. So for any other, for the your model splitting out any negative value, it will take it as zero.
Okay, sorry, I missed some questions with hashtag now, which should have been asked earlier, but let's see if this makes sense now. So one question was,
actually,
how do you...
I have another session which I'm organizing now. So I'll have to leave now. But what I would recommend is like follow me on Twitter, and you can.
I think there are only two more questions.
And okay, so we have an NLP session coming up, so which I'm organizing. So I'll just have to catch up with speakers and stuff. So I mean, Tell me the questions. I'll see if I
So,
can handle it
how
quickly.
do you decide how many and what kind of deep layers to use?
So see, all these things will be like, say, there's no fixed rule that this is how your model should be. So it's all with experimentation only. So there are already some predefined models, which I'll explain you one thing called TensorFlow Hub. So there's no hard and fast rule that this is how these are the many layers which you should use and all. So since many of you who have come to this section are absolute beginners, what I'll do is, for absolute beginners, I have covered something very basic of neural networks and all of this, right? Now with this knowledge, you want to go, what is the next level for you to get started with is something called TensorFlow Hub. So if you go to TensorFlow Hub, so you have some state of the art models. State of the art models is like, the models which will have some predefined architectures and all these things. So these models are used for solving certain problems. Like this is, or you can just Google out TensorFlow Hub.
Is there?
So TensorFlow Hub is a website. You have something TensorFlow Hub Home. The reason why I'm telling you is this is a great place for you to try out a lot of problems with just few lines of code. You'll really appreciate me if you dig into it. So you go to TensorThub and so there are three major problems. One is image, problems dealing with image, problems dealing with text, and problems dealing with video, right? So under all these problem domains, you have got this architectures, predefined, the state of the art architectures already given to you. So you'll find all the models here. So if you just click on
Great.
TensorFlow 2.0, and then if you check out what are the models in the text, you'll get the set of models. So you click on any of these models. So for a text classification, I don't want to deal with text. We are dealing with images right now. So go to images. So I'm clicking on images. So there are some common problems in images, right? Image classification, image augmentation, and all this. So image classification is a problem we are dealing. Right now, there's another domain called object detection and all that. So as a beginner, you don't want to. You may not have GPU resources also. If you're writing a very complex model with lot of layers and all that, you may not have that kind of a compute resource to get started with. You want to perform object detection, but you as a beginner, you don't have that kind of a compute resource, but you still want to do an object detection. This, for object detection, there are several state of the model art models which has come up. So this, out of these state of models, you can just directly import those state of models into your program with just 3-4 lines of code, and then you can start making inference out of it. You don't have to sit and build a new. For object detection, you don't have to sit and you are already a beginner. For object detection, sitting and writing complete architecture from the scratch might be overwhelming for you. So go to tfhub.dev. I'll just share this URL also in the comment section. Go to this thing. And for most common image problems like classification, object detection, all these problems, if you go for object detection and all that, you've got all the state of the art models here. So just import those models and start making predictions. So as a beginner, it might be little less overwhelming for you to quickly see, and you may not have the compute resources for, computing a very, higher end model and all that. So as you deal with these basic models, you'll slowly start getting an idea how to build your own custom network and all. Again, there's no hard fast rules like you should have only these many layers and all that. It's like use case by use case and trial by a trial error is what you decide. But how do you come up with some complex architectures? Is there are a lot of state of the art models which are out there. Start exploring these models, and there's also a platform called Kaggle. So to go to Kaggle, the reason why I'm saying go to Kaggle is, so go to kaggle.com, and under the so under compete, you have got a lot of competitions which are currently live. So these competitions, a lot of people would have come up with new architectures. In addition to the state of right now, there's like melanoma classification. This is an image classification problem. So there are a lot of image classification problems. You go to these problems, and all this has a price tag attached, 30,000 US dollars and all that. So go to these problems and start exploring it. So for each of the competition which got over, most of the competition which they got over, the prize winners, all of them would have shared a notebook where they would have put whatever custom architecture they would have used, they would have shared that custom architecture. So basically, if you want to get started with writing your own custom architecture and all that, this is a good way to start with tfhub.dev. First, get a hold of it. If you are a very much beginner, don't have the computer resource, and then start exploring these state of art models. Come to Kaggle, and a lot of people have put their winning solutions and all of it outside. Start exploring these models, and then after a certain point, you'll be able to write your own. Provided you have, I mean, Google Colab has got free GPU, but again, it is like comes with a tag. Like you may not be able to, there's only a restrictions on the RAM and how many hours, if a model is running for more than 12 hours, 13 hours, and all these restrictions on there'll be some difficulties in getting a lot of things done, although it's a free GPU. So they have come up with something called Colab Pro and all. Go check out if you're participating in competitions like Colab. And Colab Pro is again only $10 per month. Still, you can get a lot of it done using that. And or this competition itself has free cloud credits and all, so write a question and win some cloud credits so you can get started with your deep learning right away. So yes.
Great, awesome. Thanks for sharing, Usha. And on the same line, if you need a machine, you need cloud credits. We have them. Specifically, we also have one cloud credit for machine learning algorithm. So there will be a ready-made machine that you will get. You can just get started with machine learning over that. That is being provided by CloudX Lab, and then we have cloud credits from DigitalOcean. So you can get that, and we will be sharing with all of you. But we have put one thing, one necessity, that if you can submit your feedback, for the people who submit their feedback, we will email you these credits and coupon codes by tomorrow. So Usha, thanks a lot for joining in and sharing this knowledge with you. I got to know about lots of stuff, and now I'm ready to get started with deep learning and explore with different kind of platforms and the ways that you have shared with us how to go further from here. So, and thanks a lot for the audience for asking the questions, for attending this show. Do you have any last message to share with the audience, Usha?
Get started right away. Don't be overwhelmed with a lot of terminologies which you don't understand and all that. Take the first step. Start executing that simple program and take that first step which is required. Then you'll automatically get it. There are a lot of people who have won silver medals and bronze medals in just a matter of 1 month of learning and all that. So never think you cannot do it. You will be able to do it. It all requires taking that first simple step. Best wishes for you. I would love to hear your stories of success through. Can reach out to me in Twitter at @urangaraju and tell me your success stories and all that. And thank you so much for the Invite Labs for organizing a great conferences and giving it free for the public and offering cloud credits and all, doing this great job to the community free of cost. I do wish you all the success in your future endeavors. Thank you so much.
Thank you very much, Usha, for attending us. See you.
Bye
Bye-bye.